Hi, I'm a student from the Polytechnic Ungoma. Today, I would like to present the EOC General Skill 2 of Semiconductor Devices DEE20023. My name is Ngai Ho En, and my number message is 01DTK23F1003. My course lecturer is Wano Sada Pindi Mamo. Let's see about the question this time. Common emitter configuration is shown in figure 1a, and if the transistor BC107 used in this circuit is silicon type and beta is equal to 200, calculate about IB, ICQ, VCQ, IC saturation, and VCE cutoff. Let's see. Before we starting, we need to know that the IC is equal to beta times IB and the IE is equal to IC plus IB. We can use IC equal to beta times IB and substitute it inside the IE formula. And we can get that the 201 times IB is equal to the IE. And now we can start our progress, that is to find the IB. We can see that the VBB is also connected with the VCC and it is like the parallel connection. So we can know that the VBB and the VCC are the same value of the voltage, that is 220 volt. See the formula first. The VBB is equal to VRB1 plus VRB2 plus VBE plus VRE. This is based on the voltage divider rule. And the VRB1 plus VRB2 can write in IB times RB1 plus IB times RB2. And the VIE we can write inside the IE times RE. Since we know that the IE is equal to 201 times IB, so we can substitute it to 201 times IB times RE. And the VRB1, VRB2 we can write it as the IB times RB1 plus IB times RB2. Some of you are already know that, see that we got the 3 IB times here. So we can take the IB out and write it inside IB times RB1 plus RB2 plus 201 times RE as an equation and plus VBE. Since our transistor here is the silicon type, so we can know that our VBE is equal to the 0.7 volt. And we can write our formula as this. IB equal to VBB minus VBE per RB1 plus RB2 plus 201 times RE. And we put the value inside. Just I mentioned just now, the VBB is same as the VCC, 20 volt, and the VBE is based on the transistor we use, his type. If it's the germanium type, we need to use 0.3 volt. But here is the silicon type, so we use 0.7. 20 minus 0.7 and per 2K, we can know that the RB1 is equal to 2 kilo ohm and the RB2 is equal to 600 kilo ohm. And the 201 is our equation, our formula here, and the IB is and the RE is equal to 200 ohm, and we can get 30.05 microampere. Next, we see how to find the VCE. Since just now we find the input, now we can find the output in this circuit. That is the VCC equal to VRC plus VCE plus VRE. Now we can see that the VCC, this equation also based in the voltage divider rule. We can see the VCC, the current pass through to the RC and pass through to the transistor and pass through the RE. And we can know that the voltage at here VRC, voltage at here VCE, and the voltage at here VRE, their equation are same as the VCC, that is 20 voltage. And then we can use this equation, that is the VCE equal to VCC minus VRC minus VRE. And we can change the equation VRC into IC times RC and the VRE into IE times RE and substitute the value we can use right now. That is the IC, RC, IE, and RE. The IC and RE is the value we find just now. Here, IC equal to 6.01 milliampere and the IE equal to 6.04 milliampere. Substitute into the equation and we can get the VC is equal to 6.77 voltage. Next, to find the IC saturation, we need to consider that the VCE is equal to the 0 voltage. And if we need to find the IC saturation and the VCE cutoff, we need to use the equation that is the output in this circuit, that is the VCC equal to VRC plus VCE plus VRE. Since the VCE is equal to 0 voltage, so we just ignore it. The VCC is just equal to VRC plus VRE. And we can substitute our formula into VRC is equal to IC times RC and the VIE is IE times RE. And change the formula, IC saturation is equal to VCC minus IE times RE per RC. And sub the value we get just now and we can get the IC saturation is equal to 9.396 milliampere. And last but not least, we need to find the VCA cutoff. To find the VCA cutoff, that is IC, we need to consider the IC equal to IE and they are both 0 ampere. So the VCC also, we need to take the output in this circuit, that is the VCC equal to VRC plus VCE plus VRE. To make it more clearer, I make one more equation that is VCE is equal to VCC minus VRC minus VRE. And we can see that the VRC and the VRE, they has IC and IE. And both of them are equal to 0. So we can just ignore the part that have IC and IE and we only left the VCC. So we can note that the VCE cutoff is equal to VCC and the VCE cutoff is equal to 20 voltage. That's all for my presentation. Thank you for watching. Have a nice day.